Alright guys, let's talk vector databases. Imagine trying to find a specific face in a crowd of millions. That's essentially what AI applications have to do when dealing with massive amounts of unstructured data. Traditional databases, which rely on structured data like names and dates, just aren't cut out for this type of search. That's where vector databases step in. They're specifically designed to handle unstructured data, like text, images, and audio, by representing each piece of data as a vector. Imagine a point in a multidimensional space. Each dimension corresponds to a unique feature or characteristic of the data, like the color of an image, the tone of an audio clip, or the meaning of a word in a document. This allows for similarity searches, making it super fast and efficient to find data points that are close to each other in meaning or content. Vector databases excel at finding those needles in a haystack, but not just one needle at a time. They can sift through billions of vectors and find the most similar ones in a flash, opening up a whole new world of possibilities for AI and generative AI. So, where does Pinecone fit into this picture? Pinecone is a leading vector database platform built specifically to meet the demanding needs of AI applications. Think of it as the engine that powers AI-driven search, recommendation systems, and even sophisticated chatbots. Pinecone isn't just storing data, it's managing, organizing, and retrieving information efficiently, even at massive scale. And the best part? It's super user-friendly. Pinecone simplifies the process of adding vector search functionality to apps with straightforward APIs and SDKs. This means developers, even those without deep knowledge of vector search, can easily integrate Pinecone into their projects. Plus, it's a fully managed service, so no need to wrestle with infrastructure, scaling, and maintenance. Pinecone takes care of all the heavy lifting, so you can focus on building cutting-edge AI features. They've even introduced a new API to help with agent-based applications, which simplifies RAG development. Pinecone now also offers AI inferencing capability, basically running code from the vector database to provide better results for RAG. With Pinecone, building intelligent apps is easier and more efficient than ever. Now let's talk Retrieval Augmented Generation, or RAG, the secret sauce behind many of today's most powerful AI applications. Imagine you're having a conversation with a chatbot. You ask a complex question that requires specific knowledge the bot doesn't have by default. That's where RAG steps in. It retrieves relevant information from a massive external knowledge base in real time and adds it to the conversation. This allows the AI to generate more informed, accurate, and helpful responses. What makes RAG so groundbreaking is that it allows us to leverage the incredible language capabilities of LLMs while grounding them in real-world knowledge. Pinecone is an ideal vector database for RAG because of its ability to quickly sift through vast datasets and pinpoint the most relevant information. This dynamic duo is changing the game in fields like customer service, content creation, and even medical diagnosis. We're starting to see LLMs become truly powerful assistants by getting knowledge from the world and also from the company's internal knowledge. Managing the infrastructure behind a vector database can be a real headache, especially as your data grows and your application scales. But what if you could just focus on building your AI feature? And Pinecone is right at the forefront of this revolution with Pinecone Serverless. Pinecone Serverless takes all the complexity out of managing the vector database infrastructure. It automatically scales up or down based on your needs, so you only pay for what you use. This is a game changer for cost efficiency and makes it easier to handle spikes in traffic without performance issues. Pinecone Serverless uses cloud-native technologies to deliver incredible flexibility and performance, allowing you to build AI applications that are both powerful and cost-effective. It's a huge step forward for making AI accessible to organizations of all sizes. Let's get practical and explore some real-world examples of how Pinecone is making a difference. Imagine an e-commerce platform that wants to provide personalized product recommendations. By embedding product characteristics and user purchase history as vectors, Pinecone can quickly identify and surface the most relevant products for each shopper in real time. Or, think about a news aggregator. Pinecone can power a personalized content recommendation system, giving it the ability to perform semantic searches by matching your queries to embeddings representing the meaning of articles. It can even be used in healthcare to accelerate the development of AI models by managing the vast amounts of unstructured imaging data needed to train and fine-tune AI models. The possibilities are endless. We're seeing Pinecone used in everything from semantic search engines to real-time recommendation systems, revolutionizing how we interact with information. Pinecone is undoubtedly a powerful platform, but it's not the only vector database out there. It's important to consider the alternatives to find the perfect fit for your needs. Open source options like ChromaDB offer excellent functionality and are great for those who prefer to have more control over their database. Other platforms like ActiveLOOP's Deep Lake focus on AI-specific use cases, organizing and managing diverse data types for machine learning projects. Milvus is another leading open-source competitor that excels at handling massive vector datasets for similarity searches. And don't forget about platforms like Weaviate and Grant that each offer unique capabilities. Even some document-based databases now support limited capabilities like embedding, which can make them a good, open-source competitor to Pinecone. Each option brings its strengths and weaknesses, so it's essential to evaluate them based on your specific requirements, whether it's scalability, cost, or ease of integration. Of course, the world of vector databases is still evolving, and with any new technology come challenges. One of the big ones is the increasing volume and complexity of data. Vector databases need to be able to handle this influx of information efficiently without causing bottlenecks and performance issues. Another challenge to Pinecone's popularity is the cost of using it, which is based on using its read and write units, along with the storage capacity. Security is essential, especially for organizations dealing with confidential information, which makes it imperative for vector databases to provide robust capabilities for data protection and governance. Developers are finding new ways to integrate different components from AI and backend systems, ensuring that vector databases are designed and operated in a secure way. Looking ahead, we're likely to see more innovation in how vector databases handle these challenges. The introduction of new indexing and retrieval algorithms and the use of cloud-native technologies can help to address them. There is also lots of research going on in improving information retrieval in these databases by trying to minimize loss of information using something called lost-in-the-middle mitigation methodology. The future of vector databases is bright, and we're only scratching the surface of what's possible. Chroma is a strong open-source contender in the vector database arena. Designed for simplicity and ease of use, it integrates seamlessly with Python, making it a popular choice for developers. It excels at handling large data volumes without compromising performance, which is a crucial factor in AI applications. Chroma is designed with LLMs in mind, offering efficient storage and retrieval of vector embeddings along with associated metadata, providing a richer understanding of data and boosting performance analysis. Its focus on embedding metadata makes it stand apart from Pinecone and allows for context-based retrieval, helping AI apps derive more meaningful insights from data. However, being primarily Python-centric might limit its appeal for developers who prefer other programming languages, especially as it is a relatively new project. Having been downloaded hundreds of thousands of times, it has garnered substantial community support, making it a promising solution. So, if you're looking for an open-source vector database that's Python-friendly and excels in LLM applications, ChromaDB is definitely worth a look. Now, what if I told you that your good old PostgreSQL database could handle vector searches? Enter PyVector, an open-source extension for PostgreSQL that adds vector capabilities to this popular relational database. This makes it extremely cost-effective, especially considering the high costs associated with some dedicated vector databases solutions. Recent open-source extensions have made PostgreSQL even faster for AI applications, opening up large-scale, high-performance AI use cases that were previously only possible with specialized vector databases like Pinecone. Its optimized algorithms and innovative index types actually help it deliver better retrieval quality than specialized vector databases. There are now extensions available, which bring more AI workflows to PostgreSQL. This, in turn, makes it easier for developers to build search and RAG applications, while also helping them with OpenAI embeddings and OpenAI chat completions. PyVector seamlessly integrates with existing PostgreSQL installations, making it easy to add vector search functionality without migrating data. It's now gaining traction amongst developers who value the versatility. If you're already working with PostgreSQL and want to dip your toes into vector search, PyVector is a fantastic starting point. With PyVector, PostgreSQL has become a serious contender in the vector database landscape. If you're dealing with massive amounts of data, then Milvus is a vector database that has been specifically designed for handling similarity searches at scale. It's popular with data scientists, AI researchers, and machine learning engineers. Its scalable architecture and optimized indexing algorithms ensure fast and accurate similarity search results, even as your datasets grow into the billions of vectors. Developed primarily for large organizations and enterprises, its architecture ensures accurate similarity searches, while the managed cloud offering streamlines the deployment and scaling complexities. Milvus also simplifies integration into applications with SDKs across various languages, making it accessible to a broader range of users without deep infrastructure knowledge. Milvus is a strong contender if you're developing AI applications that demand resilience and performance, and is worth exploring for its efficiency in handling image and video similarity searches. While it allows for easy integration into your code, it does have the downside of steeper learning curve, especially when using complex features.